An unexpected movement of Earth's surface is called an earthquake. When two parts of Earth's surface move suddenly in relation to each other along a fault line due to tectonic forces, an earthquake occurs. An tremendous amount of energy is released in the form of tremors and vibrations. Such earthquakes are called tectonic earthquakes. The point of origin of an earthquake is called focus, while the point directly above it on the surface of Earth is called epicenter. Owing to the strong vibrations around the point of origin, the degree of destruction is greater around the epicenter.
When these earthquakes occur, they don't occur alone. Many other phenomena also occur with it, and there is no limit to it. They are shaking and ground rupture are the main effects created by earthquakes, principally resulting in more or less severe damage to buildings and other rigid structures. Landslides. Earthquakes along severe storms, volcanic activity, coastal wave attack, and wildfires can produce slope instability, leading to landslides. Fire. Earthquakes can cause fires by damaging electrical power or gas lines. Soil liquefaction occurs because of shaking. Water-saturated granule material such as sand temporarily oozes its strength and transforms from solid to liquid. Tsunamis are long wavelength, long period sea waves produced by sudden or abrupt movement of large volumes of water. World's 65% of population is staying near coast, and these coastal areas are more vulnerable towards earthquakes and tsunamis.
The branch of knowledge that deals with the study of earthquake is called seismology, and the experts who study seismic waves are called seismologists. There are two types of seismic waves that spread in all directions from the focus. They are P waves and the S waves. The compressional waves are the first to reach the earthquake recording station, as they travel 1.7 times faster than the shear waves and are therefore called the primary or P waves, while the shear waves are called secondary or S waves. The primary waves cause the particles of a rock to vibrate forward and backward in direction of the waves. Secondary waves, on the other hand, cause the particle to oscillate at right angles to the direction of the waves. A seismogram is an instrument used to measure the movement of an earthquake. A weight is suspended in a way that it allows to remain still when the ground moves. Most modern instruments use electromagnetic mechanism for this. A riding instrument is attached to the weight, allowing it to record the movement as it happens. The word graph is referred to a riding action. Most modern earthquake monitoring uses seismometers and not seismographs, and record the movement of the earth digitally or output the data to a seismogram, a printed version of the wavelengths. These wavelengths that represent Earth movements are so small that in order for scientists to study them, they have to be amplified.
For getting better understanding of seismograph, we ourselves made a working model of it. We took a cardboard box and punched two holes on its side and one on the top. Same way, by taking a plastic cup, we punched two holes on its sides and one at the bottom. Further, we fixed a pen inside the plastic cup with help of a clay. By using two strings, we connected the holes on the plastic cup with those on the sides of the cardboard. Then we tied a string tight around the pen and passed it through the hole on the top of the cardboard box. Our seismograph is now ready to work. The following video clip shows the actual working of a handmade seismograph. One of them is to plan out earthquake emergency exit maps. These maps direct the crowd out of the building in such a way that there is no rush in any of the exits. It is mainly the rush and fear among the people which increases the number of deaths. The map clearly shows which exit is to be followed by people in different areas. People should even take the maps of their own house and plan certain exit gates for it in emergency.
If you are at home, first move under a table or a desk to protect your body. Calmly extinguish any fires if possible. Protect children and the elder people. If the power supply is suspended due to the earthquake, switch off the circuit breaker. When the power is restored, check the safety of your appliance before you switch the circuit breaker back on. If you are driving, slow down gradually and stop the car on the left-hand side of the road. If you exit your car, leave your key in the ignition and don't lock the door. If you are in a department store, train, in a build-up area or in a theater hall, guard your head with your bag or a similar object and stand near a wall or a pillar. Stay away from a glass and display shelves. Follow the instructions of the crew.
What was your presence of mind and what should you do? You were active that time or you were just blank what to do and all?
That time I was in Ahmedabad. So the day it's like 26th January. It was morning, so we were just getting ready from day-to-day activities. And suddenly it vibrates, so you have to just figure out that it took time to figure out that it's an earthquake. Because that's one kind of first experience. And then we have to go out of the house. And I was fortunately on the ground, so there was no issue.
What was the situation of other people? Were they panic?
A couple of buildings got a heavy cracks, so there was sound around it. But by the time they realized, most of the people realized that it's an earthquake and it's a large quantum, the time got so. Because the panic is not at the time when the earthquake strikes. The panic take place when you realize how destructive it is.
Sure, can you give a small glimpse of what is your experience of the earthquake happening in 2001?
Okay, an earthquake that happened in 2001. I'm from Ahmedabad and I used to live on the 6th floor. My flat is on the 6th floor. So early morning, because we had a long night before, we woke up late and both of us were in bed, me and my wife, and we suddenly felt a shaking. And my initial thought was, dabar hatao. I said, why should we be dropping the building, without even vacating the occupants? But soon as I saw the flats swaying from side to side, I realized that it was an earthquake. And I looked out of the window and I saw one building just go down. And that was Ayodhya Apartments. This was just about 100 meters from my home flat. And quickly, before I could do anything, my wife said, "Ki tame brush kari lo, jara cha banai." I said, "Nothing doing, let's run down." And we ran down, and because the electricity was cut off, we ran down and we went to an open ground, and we saw the Ayodhya go down. And as we went down, there was this neighbor of ours, Vijay uncle, he said, "Hey, chalo, apne bada मैदान में जता रही है." I said, "Why?" He said, "मारो सारो से संदेश મોકલ્યો છે કે 10 વાગે બીજો અટેક આવવાનો છે." I said, "વિજય તમારા પોતાના ભાઈ ગયો." And you know that an earthquake cannot be predicted. તમે તમારા ભાઈની વાત માનો, તમારી બાયડીના ભાઈની વાત ના માનો. It cannot be predicted. His own brother is materialized. And after that nobody allowed us to actually enter the flat for about a week. So I stayed at my in-laws, and for that night we slept in the shop.
How are earthquake-resistant buildings made?
Oh, a good building is an earthquake-resistant building anyway. So first, what we have to understand from an earthquake is also that it is not earthquake which kills people. It's building which kills people. Let me just clarify that. No? We say this earthquake-resistant building and earthquake-proof building. As such, there are no buildings which are earthquake-proof, because the kind of earthquake Kutch had, it's of a very large quantity, and no building can withstand without giving a budge to those kind of forces. So, if that kind of earthquake occurs, your building may crack, it may go through a severe damages, but it should not fall apart. You may have many cracks in building, but as long as this slab does not fall or this wall does not fall, you're not going to die. The building is not completely collapsed. It will still shelter. It will still stand up. What can be done specifically, it's a highly technical job. But what we can still talk about is make building lighter. That's point one. If the building is lighter,
You mean hollow bricks we should use like that?
Sorry?
Hollow bricks. Nowadays, white brick or something
Yeah,
like that.
hollow bricks can have greyish brick which you are talking about. It's called arretted blocks. The arretted blocks can help, because the later the mass, the later the inertial force a building will attract. Right? If you have a bulk here and if you push it from the down, it will have a greater inertial force, because the mass is on top. Like for the pen, we can talk about this pen. There is a greater mass on top. Now when it hits like this from an earthquake, from the ground. But the larger mass on top, it will have a greater inertia force. If you put it other way around, if the weight on top is lesser, the earthquake forces will be lesser affected.
Okay.
So that is by creating a lighter building, that's one which helps you.
You are telling that buildings should be narrow, what we said?
Lighter.
Lighter, a pointer from upwards. You mean to say that?
No, I don't mean to say that. Because pointer is too literal.
Not pointed, narrower.
It's too literal. Lighter, you can make it like water tank is heavier on top. If you see a water tank, the city's water supply tank, which is like a bulk, a very large mass on top. When you see it is almost this. So when there is a huge mass here, this will attract a lot of inertia force. Because the force transferred to the building from the ground. But this will have a higher inertia force, so there is a greater chance of it toppling down. Now if you have a building other way around, so like this, which you are saying very literally, but this way there is a greater mass on bottom, so the inertia force will be lesser. But you cannot have this kind of building. So what I mean lighter is that if I have a building, the slab, the RCC slab is heavier. This is heavy. It's having greater weight. But instead of this, if you have this kind of roof, it's lighter, because this is made out of wood or steel and a tile. But this is made out of concrete and steel. So this is much more heavy than this is much more light. So this can give us a lighter roof. Will have a less attraction of an inertia force. Or for your high-rise building, we generally have buildings like this. Right? What is this? This is parking.
Yeah.
And then you have floor on top. Right? So parking or shops or something like that. But this means there are a lot of walls here. There is no wall here. There are only columns.
Pillars.
Pillars. They are not pillars, but they are columns. But anyway, whatever you understand. But this means this is a direct translation of this. Let's see conceptually.
Yeah.
There is a weight on top. It's very light on bottom. It's very light on bottom. So this is what I mean by a heavier building from top. So if you have this, I mean, if you do not have any walls on the ground floor, your building becomes light on ground and heavy on top. And that will attract a greater amount of force from an earthquake. That doesn't mean that you should not have a parking on the ground floor, but you need to have a provision for it. So now you can have some part of it have a wall between columns, but still you can park. One of the wall fall out. If one of the wall fall out, the roof will fall, because the roof is standing on either of those walls. So if you ensure that no single wall fall, they will perform better. And for example, when you have this these walls acting separately, and when you vibrate, they fall apart like this, because they are acting separately. Their base is only this wide, so they don't get instability. They are standing free. But by some means, if you tie them, if you take a thread and tie these books from,
They will be dependent upon each other.
They will be working together. When they start working together, they perform better. So that's some second way you can do it. How you can do that? You might have seen this, where we cast a lintel above a door. You have seen any building which is under construction?
Yeah.
You do these RCC lintels on top of the windows and doors.
Yes.
Yeah? One small 6-inch thick band. Now instead of having it only on the doors, if you put all across, it is like a thread tying these books. You are tying a wall. If you tie the walls, it will perform better. Rather than having two large windows, if you have small windows, it will perform better, because you will have a greater wall area.
Yeah.
When you have a greater wall area, you will have more area to take care of your forces. So smaller windows and doors will help you to perform better, help the building to perform better. Larger the puncture, the performance will get bigger.